Hello, welcome back. In this video, I'm going to discuss about the continuity of the piecewise function f of x. So for x equals 1, the function is defined to be 2. When x is less than 1, the function is just x. And when x is greater than 1, as you see, the function is 2x minus 1. We have three conditions for continuity. One is that the function is to be defined at the point, and the limit of the function should exist at that point, and the limit value should be exactly the same as the function value. Well, as you look at those pieces here, x and 2x minus 1, these guys are polynomials, and polynomials are well-defined functions, and their function values are exactly the same as the limit values. So x and 2x minus 1 are continuous functions in their domains, right? Either x is greater than 1 for this function or x is less than 1 for this function. So the only problem point here is x equals 1, because in one side of that there's one function, in the other side of that there's another function. In fact, the function is defined to be equal to 2 at that point. So our first task is to check the first condition. F is defined, so f of 1, which is 2, is the value of f. Okay, so check mark for the first condition. In the second condition, we're asked to find the limit of the function. Okay, but since this is a piecewise defined function, we have left and right limits. Okay, so I'm going to check limit as x approaches 1 from the left, and then limit x approaches 1 from the right. Okay, for the one from the left here, we're going to use the top function, which is x, and for the right limit here, we're going to use the bottom function, which is 2x minus 1. Right? Since in both cases we have polynomials, this is going to be substitution. So this is going to be just subbing 1 for x, and then we get 1 here, and subbing 1 for x here takes you all the way to 1. So the good news is that left limit is exactly equal to the right limit, so which essentially says that the limit exists. Okay, what is that limit value? So limit of f as x approaches 1, not from the left or right, but just 1, of f of x is equal to 1. We put a check mark here. In the third condition, we check if the function value is the same as the limit value. Well, unfortunately, function value is not equal to the limit value, because the limit value is found to be 1 and the function value is 2. 2 is totally different from 1. That makes the third condition fail. So the conclusion here is that f is not continuous at x equals 1. But as we claimed before, f is continuous whenever x is not equal to 1. So to wrap up, is continuous for all x except plus 1. As a side comment here, we can classify the discontinuity of the function. We can remove the discontinuity by redefining the function. And the way you redefine the function is to remove the second piece here. So if you remove that, and if you put the equalities here, greater than or equal to or less than equal to inequalities, then the redefined function becomes continuous, because the limit of the function would be exactly the same as the function value. Again, we're removing the second piece here, and we're putting equalities here and here. Okay? And here is the graph of this piecewise function. So as you see, there's a hole here because the function is defined to be 2 at x equals 1. And right piece is this line 2x minus 1, and the left piece is y equals x. All right, and following up my comment about the removable discontinuity, we can redefine the function in a way that we remove this dot here and we fill this piece here so that the function value becomes 1 at this point, so that without any break you can graph this line. All right, that's the end of the video. I'll see you in another video. Bye.